Hello everyone, welcome back to another episode of Lopez Honors Pre-Calculus Guide. This is take 2 because 15 minutes into take 1, I realized I wasn't screen recording. Anyways, so this is about the law of sines. So that just has to do with this big equation here. Sine A over A equals sine B over C equals sine C. This is pretty easy to remember. You just gotta make sure that your angle A is opposite side A, not next to, has to be opposite, and same with angles C and angle sides. Make sure they're just all opposite of each other, or else you get weird answers. It won't work. So the first type of problem you'll see with this is when you're given two angles and a side. So what you need to do here is, well, first let me just write down everything that we need to solve for. So we need to solve for B, or side B, side C, and also angle A. I'll just write that down to the side, make a key for myself. So the easiest thing to do first is solve for angle A because all the angles will add up to 180. So that means that A plus B plus C is 80. B is 10. 32. So A plus B plus C equal 180. And then you solve for this. A is just equal to 38 degrees. So I'll write that down. And then we can use the law of sines. Sine A, which is 38 degrees, over A, which is 39, equals sine B, which is 110 degrees, over B, and then that equals sine C, which is 32 degrees, over C, which we don't know yet. So first, it's kind of hard to work with an equation, three sides, so we'll just look at these two first and ignore this for now. So how we solve this is we just cross multiply the butterfly method, the other thing they call it. Anyways, so what you get is B sine 38 equals 39 sine 10. We're solving for our unknown variable, which is B, so we just divide both sides by sine 8. And then what you get is B equals 59.526 when you plug this in. So down 59.526. And then we can do the same thing with side C. Let me rewrite our equation. So now we'll be ignoring B and this part. The first part we can keep the same, sine 38, 39. Set that equal to sine 32 over C. Do the same thing where we cross multiply. C sine 38 equals 39 sine 32. And then C will be equal to, solve this, 33.569. That is the answer. We solved all the parts of the triangle. So that is pretty much the simplest case, easiest one. Just solve for a third angle, then use law of sines, and then cross multiply, and then figure out the remaining two sides. Alright, so now we're going to go to the ambiguous case. I don't know what ambiguous means, but basically in this context, it's a case where you have two sides. You're given an angle that's opposite to one of those sides. And so the reason why it's called the ambiguous case is because these are either 0, 1, or 2 triangles. So two types of ambiguous cases. The first one is when you're given an angle, the angle that you're solving for greater than the angle that you're given. And in that case, there's 2 triangles or 0 triangles. Then there's the other one where the angle you're trying to find is less than the angle you're given. In that case, there's 0 triangles. So let me show you how you would identify each case. So let's say, there's angle A here, and then the side that corresponds to it has a length of like 6. And then side B, we're also given side B. Then let's say this is like 13. So we need to remember something important about triangles. One of the rules about triangles, that is that basically bigger sides of the triangle, like this is the biggest side, will correspond to the biggest angle of the triangle, and like this is the smallest side, that'll correspond with the smallest angle. It's kind of like medium size that corresponds with like a medium size like side, I guess. But basically, small angles, small sides, big angles, big sides. So that's important because based off that, we know that because B corresponds to a bigger side, that must mean that angle B greater than angle A. And then similarly over here, if we have like, say A is still 6, and we're solving for B, and B is say like 3, then we know that angle B has to be smaller than angle A. And so in a problem, you'll be given angle A or B's angle, where then like, say we're given angle A is equal to like 30 degrees or something, then we would know that B is greater than 30 degrees. Then let's say here angle A was like 60 degrees, then angle B is less than 60 degrees. So basically, if it's less than, then there's 0, 1, greater than 0 or 2. So let's do an example of that. So here's an example where the angle 30 degrees corresponds with 6. And so we have given side B, which is 7. And because 7 is greater than 6, bigger sides correspond to bigger angles. Also know that angle B has to be greater than angle A, which is 30 degrees. So angle B has to be greater 30 degrees. And if we solve for angle B and we get something that's not 30 degrees, if it's less than 30 degrees, then the triangle doesn't exist because that violates the rule of the triangle. So let's use the law of sines to solve for this. So we're given these 2 values and this value. Use those. So sine of A, 30 degrees, over 6 will equal to sine B, which we don't know yet, over lowercase b, which is 7. So we can do the same cross multiplying thing, except now we're solving for an angle instead. We get 7 sine 30 equals 6 sine b. And then whenever you just divide both sides by 6 to solve for sine b. And then you'd get sine b equals 0.533. Alright, so your first instinct might be to just take the inverse sine of both sides, so you get b by itself, then figure out angle b, and then call it a day. But you can't do that because sine inverse only gives one answer, but to this equation there's actually 2 answers because 2 angles have the same sign of whatever this is. So I'll show that on a graph real quick. So this is angle A, which is 30 degrees. This is like 30 degrees. And so we know that angle B is going to be greater than that, so I'll just draw that. We don't know what it is, we just know it's greater. Assume it's like this or something. So this is angle B, right? And then sine B equals, what was it? I think 0.583. All right, now let's look at another angle over here, other side. This is a different angle now, except call this B sub 1, really. Call this B sub 2. We have two different angles. But the thing is that sine of B sub 2 is also equal to 0.83. Meaning that this has two possible angles. There are two possible angles for B. So how we find those is, well, for the first angle in quadrant 1, you can just take the sine inverse. And when you do that, you just take sine inverse of this side here and this side here. You take the sine inverse of a sine, then it just cancels out. Take the sine inverse of this side, then you would get, let me check my calculator. Oh, you get 35.685 degrees. So that's this angle over here, B. But for this other angle, what you need to do is you need to do 180 degrees minus first angle. This is one solution for B. But B, another solution, handwriting is horrible, sorry. Another solution will be 180 minus whatever this was, which is equal to 144,315. Now what happens is that you have two different possible angles for angle B, which means that there's two possible triangles. Angle A will be the same. Angle A will always be 3. But because of there's two possible angles for angle B, there's also two possible angles for angle C. So there's just two whole different triangles. So after you figure out the two different angles, you want to just solve it as two different triangles. And you use the same methods as the first part here, where you're given two angles on the side, except here you're given two angles, two sides, so it's easier, but you just do the same exact. Alright, so now for the next case, where the angle you're solving for is less than this angle. So let's look at this problem. 38 corresponds to 24, and then this corresponds to a smaller side length of 6. We know that smaller angles correspond to smaller side lengths. That means this angle D less than 38 degrees. Alright, so now what's happen is we're going to pretty much use almost same strategy as this, except till this point here. So I'm just gonna speed through that. So 938 over 24 equals sine D, which we don't know yet, over 6. Then you cross multiply sine 38 equals 24. Sine D divides by 24. Put this in your calculator. Got, what would you get? Get sine D equals 0.14. Alright, so I'm gonna use the same diagram. So this is angle E, and we'll first angle. So Similar to the other example, there's going to be two possible angles that give you the same sine of 0.154. So let's say this is the first one, sub 1. I drew it lower because we said the angle D has to be lower than E, which is 38 degrees. And so the first error here is, well, this other angle here, we just said that angle D has to be less than 38 degrees. It is clearly way more than 38 degrees. That's violation number 1. So why this angle wouldn't work? Why this angle would work? Second violation is also, let's say you add up these two angles. We need to remember that all triangles add up to 180 degrees. So these two angles are going to be less than 180 degrees, and then the third angle will be something else to bring it to 180 degrees. When you add up this angle and this angle, it is like way more than 180 degrees, which just isn't possible for a triangle. And the third angle, if you think about it, is just going to be more than 180 degrees. That's why even though there are technically two possible solutions to this equation, this just doesn't work. So what you can do is it's much easier. You can just inverse sine whenever the angle you're solving for is less than the angle that's given. And when you do that, you get D is equal to, let me put this in my calculator, 8.85. And now there's only one triangle to solve. Just use this angle D that you just found, angle E, to solve for angle F. And then you solve it similarly to this first problem that we had here, just the law of sine. Alright, the last thing I want to show, case when no triangle is possible. So I mean, just looking at this is a pretty weird triangle because angle 88 degrees, that's like pretty close to 90 degrees, which is a pretty big angle. And then angle C, well, this only corresponds to like 14. And angle C corresponds to 62, which is way bigger, 14. But we already said that this is close to 90, which is almost like half of 180. So it doesn't make sense this would be way bigger, but obviously that's not enough for a question. We need to prove it, so I'm going to do that. So let's try to use the law of sines here. Let's try to use the same logic we used in two problems. So what we know is that angle C corresponds to the bigger side than angle B does. So angle B is 88 degrees. So we know that this has to be greater than 88 degrees. So now, go back, this case, try to solve it similar to that. Use the law of sines here, so sine 8 over 14 equals sine of C over 62. And then let's cross multiply. 62 sine 8 equals 14 sine C. Divide both sides by 14. And then you put this in your calculator. Then get sine of C is equal to 4.426. So this is a big problem because there's no angle that you take the sine of that's going to give you this value. That's just not possible at all. Even if you were to take the sine inverse of this, like if you took the inverse sine of 4.426 and put that in your calculator, just get undefined. So it's a pretty big hint that something is wrong. So that's pretty much it for this episode of Recalculus Lopez on Recalculus Guide.